go to bed after this. Go back to bed. Are any of you working? I mean, other than school, I mean, jobs. No?
I don't think so.
So what do you do all day?
I mean, you
Other
just kinda
homework.
Oh,
relax. I don't know.
Schoolwork.
boring, huh? Oh, that's great. That was very nice of you. So as far as the deadlines, if you don't get them back in by the deadline, I'm not going to penalize anybody, just so we get everything turned in by May 1st. And then that's, because May 4th is supposed to be 5th, May 6th, and then April. May 4th is supposed to be our final. I don't know what they're going to do for finals. And then we are not going to worry about any more classes because we'll be finished. We won't worry about high school exams and all that junk. We're turning all this material for them and grades.
Can I quote you on that, Mr. Mitchell?
Don't, no. It's tentative. But I'm pretty sure that I'm not going to go beyond the 4th.
Okay, grab the milk.
He only works on Tuesdays, I thought.
It's gone.
This is Wednesday. We're on Wednesday.
Mondays and Tuesdays.
Oh. It's Bradley there. I don't see your pictures. I guess you don't have your video on. That's fine.
There we go.
I see
Can you see
you.
me now, Mr. Mitchell?
Yeah, I see you.
Is that better, Mr.
See the
Mitchell?
the Brad man.
Chris, you're looking like a real gamer.
Yeah.
It kind of scares me.
You been hacking into my Zoom? I don't know why anybody would want to hack into Zoom. All right. Well, how about yesterday's work? Anybody have questions on any of that stuff? Any problems or anything you want to see?
I didn't do anything yesterday. I was weed whacking all day.
Oh my God. I did that the other day. Needed my back hurt.
Number 7 on the second page.
7?
Yeah, on the second page.
Okay. 3.2, huh?
Yeah.
I'll write down the problem and see if this is correct. What this is this has a parentheses here.
And this is for 3.2?
Yeah. You can see the problems, huh? 5. Oh, I got my stylus fixed too a little bit. So it should work better. Basically, that's the problem right there. Okay, so this is a LNX problem, huh? So what this is y prime. Y equals. Okay, this is the Babs, huh? So it's B. No, it's 1 over, because we have to do a ln x is 1 over x. So if this is 1 over this mess,
Doesn't that just make it the reciprocal?
Yeah, it should just move this X up to here. Yeah, you're right. It basically is the reciprocal. You're right. Okay, so we can get that X, kind of move it up to there. So that's what we got here. Then we got to do a BABS for the inside of this thing. So it's that thing times X, B times the derivative of A, which would be what? 5x to the fourth. Minus x to the fifth minus 2 times the derivative of x, which is 1. This whole thing minus that over this thing squared. There you go, x squared. So that's what you should have. You should have, and you're right. You know, I never thought about it that way, but yeah, it's just a reciprocal. So that would be easier than kind of doing it the way I did it, huh? This would be a, I like how you said that. It's that kind of a easier way to remember it, just flipping that over. Okay, so what can we do to simplify this mess out? Let's see. Well, let's multiply that out. Yeah, let's factor. Before we factor, let's see what we got. But you're right, we're going to factor it out a little bit. So this would be 5x to the fifth minus x to the fifth plus 2 over x squared. And these could be combined right here. And this could be 4x to the fifth plus 2 over x squared. And of course, this could cancel. I think that's about it, huh? So our answer would be 4x to the fifth plus 2. If you want to, you could distribute this or just leave it as x times x to the fifth minus 2. Either way, you can multiply that out or leave it. And that would be it. All right, does that make sense to you? So you have to kind of do the derivative of ln x, which is this part, but then you got to do the chain rule, unfortunately, and that turned into a BABS. And just realize that next week you can forget all this. But you still have to remember it, but we're going to be doing something totally different. We're going to do integration, give you a little sneak preview. When you take the derivative, say x cubed, how do you do that? It's 3x squared, right?
Yes.
When you take the integral of x to the third, it's just a reverse. Instead of subtracting, we add. Instead of multiplying, we divide. So it's just going to be the reverse. That's the integration. We add 1 instead of subtracting 1. Instead of multiplying the 3, whatever we end up with for our power, we put it on top. Why is there a dog there, Hannah? What is this dog doing in this picture?
She's learning.
Oh, okay. Well, it should be a smart dog.
Yeah, she is.
This won't help with potty training, though. Okay, anyhow.
Mr. Mitchell,
Yes.
I have a question. So are we going to get our quizzes back so when we take our final, or like a grade back and stuff, so when we take our
Yeah, this is what I'm trying to figure that out. So I would like to get them back to you. They are grading. Yeah, I do grade them. So I would like to figure out a way to get them back to you. Maybe you have to pick them up, you know, or something like that. We'll put them all together and you can pick them up. But we will do a review sheet. No, we're going to have a review sheet. So that'll help too for the final. And I'm not going to put much in. In fact, I'm knocking down the final to like, if we take a final to like 10%. I'm not going to count it very much.
Okay, that's helpful. Thank you.
Hannah, I miss you.
I don't, Yeah.
Miss you too.
All right. So let's get on with today's lesson, which is kind of weird. These are just weird problems. I always forget these.
That's comforting.
They're just kind of a strange little problem. I write down, here they are. Okay, the first law, there are two different basically derivatives. Y equals, how did this come up? Y equals a to the x. A is a number. Okay, some number raised to the x power is equal to, the derivative of that is, and I don't know why I never can remember this. It's a to the x, kind of like e to the x, a to the x times the natural log of a, the number. So an example would be y equals 2 to the x. Y prime would be 2 to the x times the natural log of 2. Really a strange problem. Well, when we do e to the x, because e is basically a number, we get e to the x, right? But if we did it this way, it would be e to the x times the natural log of e, which is ln, e to the x.
Does that end up as 1?
Yeah, and that would be 1. I guess, actually, we would write it like this. Yeah, and that would end up as just 1. The natural log of e is 1. Yeah, so I guess that's why that works for e to the x. So we usually use e to the x, but once in a while you do run into a number or something to the x. So if you look at your worksheet, the first problem is y equals 4 to the x. So see if you can figure that one out. I'll give you a couple of seconds here to work on that. So it's simply, I don't know how the book does. It puts it in a different order, but I think it's easier to write it this way: 4 to the x, and then the natural log of 4.
And then that's it?
That's it.
Oh.
I know it's one of those derivatives we don't use very often, but just in case it would come up on your final or something like that, you kind of see how it could be done. But it's one that I usually don't memorize. I just I have to look it up every time I use it.
Is this like when we learned mixed numbers in 3rd grade because they wanted us to, but then you never use it again in your life?
Right. Kind of.
Yes.
But
Yes,
you
they
do
did.
use mixed numbers, like 3.5, you mean?
Yeah.
Don't you use those?
Just use an improper fraction.
Well, yeah, you could do it that way too, I guess. But I'll show you a little trick with these. Say you want to multiply that by 6. I remember one time doing this with my dad. You want to multiply this by 6. So all my dad did is he said you take half of 6 is 3, and then 6 times 3 is 18, and 18 plus 3 is 21. That's how he did it. I thought, well, that was pretty clever, as long as you could take half of that number. And
What
then,
happens when you get a 7?
I don't know. We never got that far. Okay, well, if you had a 7, it'd be 3.5, I guess, plus 21, which would give me 24.5. You know, I don't know. Anyhow,
I'm going to stick to decimals.
he showed me that once, and I was pretty impressed because my dad really didn't have an opportunity to go to school. So he only went up through the 6th grade, and for him to figure that out, really what he was doing was he was writing it like this, and he was doing the distributive property, and he didn't realize he was doing algebra. But I was pretty impressed. I remember one time. Yeah, it was pretty good for, but he worked with fractions all the time. So, okay, how'd you do on this one? Did you get it right? Pretty simple. I mean, there's not much to it. Okay, the other one that we don't use very often is this. We know that y equals ln x is, y prime is, and we do use this one a lot, 1 over x. We will use that. But we don't use logs very often. We use natural logs more so. So log base, and whatever the base is, this is your base, x is equal to, the derivative of that is 1 over the natural log of a, whatever that, this could be like a 10 or a 4 or whatever, and then times 1 over x. That's another one that I continually forget how to do it. And I have to look it up every time. So I have a problem number 3. Let's look at problem number 3. Here's one of those. This could be any base. So it's the natural log of the base times the derivative of it's 1 over x. Now, I assume that if this was like an x squared plus 2, then you'd have to do the chain rule on top of that. Whatever this is. Yeah, there's been one.
I hear it.
It's been one in my office all day. In fact, it makes me feel at school when you guys make those little paper planes and throw them all over the room. Okay, so do you follow this one? It's just these are the 2 basic definitions of these, and they're just special patterns that your dog has to learn in order to pass this class, Hannah. What about, where's the little cow?
Oh, it's outside. Should I go get her?
No, that's okay. He can miss today. Is it he or a she? She, yeah, would have to be a she. Okay, let's try this one. So let's say you're on a deserted island. And
Wait, what was the answer for number 3? Was it just the 1 over ln 2 times 1 over x?
Yes.
Oh.
If you wanted to put it together, you could push it together. That's prime. 1 over x ln 2. You could write it like that if you wanted to. All right, let's try this number 3. I don't know if I can even do it. It's true race of that. No, this is number 5. I take that back. So what are you guys doing with robotics?
Nothing besides 3D printing masks, and that's Chris's arena.
Oh. How are the masks coming out? How many can you do? I mean, it takes a long time. Oh, wow. Wow. That is quite a few.
Have we shipped any to the hospitals yet? Okay.
They said at the hospital up here in Globe that they get 20 masks a week is all they get. And they only get 20 test kits, I should say, not masks. 20 test kits a week. So they can only test 20 people.
Nose goes.
Kind of poor, huh? Okay, let's see if we can figure this one. Y prime equals. Okay, I got to look at my problem again. This is a to the x. It's this one right here. Oh, it's acting up again. And y prime would be kind of fits this pattern, but this would be, okay, the natural log of the number times (12 to the 7x minus 4). But then I think we have to take the derivative of the 7x minus 4 times 7. It's still chain rule. So it's the natural log of the number, then it's the original problem, and then it's the derivative of the exponent. So altogether, how could we write this? You know, you could probably just leave it like that, but I'd put 7 and 12 times 12 to the 7x minus 4. So you still have to do a chain rule on these. You have to depend on the exponent. It's kind of an awkward little mess. That's why I gave you a worksheet on it, but or a little quiz on it. But it is kind of one of those things that you don't use very often, and when you need to use it, you forgot it anyhow. The other ones are easier, like e to the x is e to the x, and ln x is 1 over x. But this one's pretty hard. And like I said, it very seldom comes up. But all right. Of course, they might do something like this. On your test, you might see something like this. So let's see if we can figure this one out. This would be, you already forgot, the natural log of 8 times the original problem, or vice versa, times the derivative of sine x. You remember what the derivative of the sine of x is? Yes. And I suppose if you just left the problem that way, it would be fine. So on your, you know, maybe the final or something, they would give you a problem like that. And it's, you know, you can use notes on the final and you can use these things. One last one, let's go back, let's erase this. Let's try one like number 6. This is one of those things that I've never really worked with a log in base 23. You know, it's one of those kind of impractical problems. Okay, so this is 1 over to the natural log of the number of the base. 1 over the natural log of the base times what? 1 over the, whatever this thing in the parentheses is, times the derivative chain rule again of this thing, which is just 9 times 9. So it's 9 over, right, ln 23 parentheses 9x minus 12, if you want to condense, I guess. And that would be it. So just prepare to do chain rule on these, huh? Okay, then at the bottom of the page, you got a couple review problems with L&X and E to the X, because those are the ones you use the most. And I'll let you work on some of those and see if we can figure them out. So I guess that's all we're gonna do today, work on this silly little thing. Make sure you write down, let me write it down one more time, the properties, in case you didn't get them. You do want to write these down. Let's change this from an X to a U. So it's L&A times A to the U, whatever this is, times the derivative of U. Or expand the problem just a little bit. So when we say that, that means chain. We have a little young kids wanting to learn this stuff. What happened there? Okay, and then the other one was y equals log a u. We'll put it like that. And y equals 1 over the natural log of a. There's proofs in the book on how to do these things, and I didn't go into that much detail on these. Du over dx. And again, we want to use chain rule right there, if we need to. If this is a nice number like 2 or 5 or something, we wouldn't have to do that. Any questions?
Did you cover e to like something like e to the 2x in the yesterday's class?
Yes. So e to the 2x
Yeah.
would be, the derivative would be e to the 2x times the derivative of the 2x, which is 2. So it would be 2e to 2x, yeah.
Awesome.
Mr. Mitchell,
Yes.
I wasn't here yesterday, so where do we get all the new assignments? Do we have to go to the college to pick them up, or do you email them to us? They're emailed? Because I didn't get anything.
They're going to be emailed as an attachment. But this is a good question. But if you didn't get, if you're having trouble downloading the attachments or something like that, we run about 10 or 12 copies. So you can pick them up at the college too if you got trouble reading the attachments. We send it as an attachment. But if you're having a little trouble, or maybe we're ran out of them, we put them in front of the school. But if we don't have enough, we'll write this number down, 928. Probably don't need that one, but 425-8481. That's the college's number, and there, if you call up, we're run one out to your car or something. The secretary will.
Can you just resend the email, because I can't find it.
Okay, who's talking to me?
Gabby, sir.
Oh, Gabby wants to resend. Resend. Okay, let me write it down on a piece of paper here. Gabby, resend. Okay, now we can do that, no problem. And if you don't get them, then you will, we do have copies at the college too.
Okay.
They're in front of the main door. Did you ever find out if you want to drop off your papers, put them in that slot? Did you ever find that slot?
I was just gonna plan on scanning in my work.
Okay, or you can, if you're a couple of days late, I'm not going to take off. Originally I was, but it's a little hard. I know for you guys to get everything done. And
is everything due tomorrow?
Yeah, it should be. Yes.
Okay.
But if you
Including
can't
this
get
week's
it in-
work?
If you can't get it on Thursday, you can always bring it by on Friday.
All right.
You send it on a Friday. That's okay.
So everything,
I'm not gonna
including,
count it wrong.
so this week and last week's work is both due tomorrow?
Yes.
Okay.
Yes.
Also, if you were not able to go to yesterday's meeting, some awesome person put it on YouTube.
Oh, very nice. Well, how would they obtain it on YouTube? What do they go to?
It's a great question. I think it's just under like Mr. Mitchell's math class, but you'll have to ask Chris.
Chris, you there? Maybe you left.
Thank you. I was screen recorded it yesterday, but I didn't get the audio, so I was bummed.
Yeah, I was looking at trying to record these, and I was just checking that out last night, and I was tired, but I was trying to figure out how to do it. So I know Mr. Leidiger records his, and he puts it on Canvas, but it's very difficult to do that. You can only record for like 10 minutes or something. But I'm trying to figure out how to record this and put it on YouTube or something. And that would be easier for everybody. But I don't know how to post to YouTube. That's my problem. I have many things I want to put on YouTube to make money. No, I'm sorry. That was no, I'm just kidding. Okay, everybody cool? Oh, I see the cow. Not very big though.
No, she's a dwarf.
Oh wow.
Look at it. It's a beautiful day outside. We should be outside doing class.
Well, do your homework outside.
I am.
If we all get our separate parking space, we can do it like a drive-in movie.
Yeah, they were talking about opening the drive-in, how they should open it, but it'd be expensive. The
That'd be
speakers
cool.
ripped out and I would think so.
Well, they need to do it.
We could put the YouTubes on the big screen. No. Yeah, chase people away. Okay, well, we're going to sign off. Enjoyed having you guys. Missed you. It'd be nice when we get back to normal. So stay healthy. That's the main thing. Stay healthy.
You too, Mr. Mitchell.
Thank you. Yeah, I'm going to try my this. I'm going to get rid of this first. And then I'm going to sign you guys off.
Bye, Mr.
See ya.
Mitchell.
Bye, Mr. Mitchell.
Bye, Mr. Mitchell. Thank you.
How do I get off of this thing?
Yeah, I'm going to